We have studied vapor pressure and we know that it depends on temperature. In this table we have temperature of liquid water and the corresponding amount of vapor pressure. Vapor pressure increases with temperature. It is true for all liquids, not only for water, but water is a convenient familiar example. At temperature 100 degrees Celsius, vapor pressure of water reaches a familiar number, 101.3 kilopascal, the standard pressure. We also know that at 100 degrees Celsius water boils. So it is time for us to redefine our understanding of the boiling point. The liquids boil when the vapor pressure reaches the outside pressure pushing down on the liquid. What kind of outside pressure are we talking about? Well, most of the time we are meaning atmospheric pressure. So, here is our new updated definition of boiling point. It is a temperature at which vapor pressure of a liquid equals the external pressure or atmospheric pressure acting on the liquid. Us, people living at the sea level, are constantly experiencing the atmospheric pressure of approximately 1 atmosphere or 101.3 kilopascal. The water starts to boil for us when its vapor pressure reaches those numbers, 101.3 kilopascals or 1 atmosphere. Now, let's go up this mountain. We are standing here on top of the mountain, and the atmospheric pressure acting on us is lower because there is literally less atmosphere to press on us. Let's say we are so high that atmospheric pressure is approximately half of what we experience at the bottom of the mountain. So it is about 50 kilopascals or half an atmosphere. If we heat up water here, it will start to boil as soon as its vapor pressure will reach that outside atmospheric pressure, which is quite low at the top of this mountain. The water will be boiling at lower temperature. We'll see all that bubbling and boiling when temperature of water will be only 82-83 degrees Celsius. So, following this logic, any liquid would have multiple boiling points depending on where you are boiling it. Here, on the mountain that we've been just talking about, boiling would occur as soon as vapor pressure is equal 50 kilopascal. So, it would be 82-83 degrees Celsius. Atmospheric pressure at the top of the Mountain Everest is approximately 34 kilopascals. So the boiling point of water there will be 72-73 degrees Celsius. At 72 degrees Celsius, the vapor pressure of water will reach the atmospheric pressure on the Mountain Everest and water will start to boil. So we end up with multiple boiling points for the same substance. To standardize the boiling point of liquids, people came up with the concept of normal boiling point. Since majority of people live at the sea level and experience normal or standard atmospheric pressure of 101.3 kilopascal, it was decided that out of multiple boiling points that a liquid might have, we call the temperature at which the vapor pressure of liquid reaches 101.3 kilopascal its normal boiling point. So for water, 100 degrees Celsius is a normal boiling point. Let's see. Normal boiling point of propanol is 55 degrees Celsius. Normal boiling point of ethanol is 80 degrees Celsius. Normal boiling point of ethanol is higher than normal boiling point of propanol, which suggests that intermolecular forces in liquid ethanol are stronger than in propanol. So, the comparison of boiling points can give us some insight on how strong are intermolecular forces in the liquid. Let's see some practice problems. The graph below shows the relationship between vapor pressure and temperature for substance X. What is the normal boiling point for the substance X? Okay, so we know that the normal point should be at the standard pressure. Over here, pressure is represented in atmospheres. Standard pressure is 1 atmosphere, so we're following the line of vapor pressure of 1 atmosphere, and we find the temperature 30 degrees Celsius. Which sample of water will have the highest vapor pressure? Well, the one with the highest amount of temperature, because we know that vapor pressure increases with the temperature. It doesn't matter how big is our sample. As long as we are given the temperature, the highest temperature will give us the highest vapor pressure. Okay, this question over here. The vapor pressure of a liquid is 0.92 atmospheres at 60 degrees Celsius. The normal boiling point of that liquid could be, well, it should be anything above 60, because at 60 it is almost atmospheric, standard atmospheric pressure. So give it a little bit more of temperature and it will reach the standard pressure of 1 atmosphere. Based on reference table H, which sample has the highest vapor pressure? Water at 20 degrees, water at 80 degrees, ethanol at 50, and ethanol at 65. Let's see how much vapor pressure those substances produce at their corresponding temperatures. Okay, so water at 20 gives us very little amount of vapor pressure, doesn't worth even speaking about. 80 degrees give us a little more. Ethanol at 50 versus ethanol at 65. Ethanol at 65 degrees Celsius clearly wins the race. It has the highest amount of vapor pressure.